All right, so we've got lesson 11 here. We're going to be using mean and mad to kind of describe our information that we've got. So no new people are showing up today. It's just talking about the other people we've met, mean and mad, a little bit more, and kind of see how information affects it there. So here we go. We suppose that the weights of 7 middle school students' backpacks are given below. So if we notice, there's our 7 lovely contestants. And if you notice the weight of their backpacks, well, they're all the same. Yeah, they're all 18 pounds. So let's fill in our chart here. In order to figure out the deviations, the first thing we need is we need the mean. So if everyone's got 18, what's the average amount? Well, yeah, that too is 18. You could add them all up and then divide by the 7, and you're still going to get 18. So there's no need to do that. So deviations, how far is 18 from 18? Well, it's 0 and 18 from 0 and 0 and 0, and you get the idea there. There is no deviation because it is all the exact same. So then the absolute deviations, go on, take a guess. Go on, I dare you. Yeah, those two are 0. Remember, absolute deviation is how far it is from the deviation. Well, but remember, it's the positive amount there. So absolute value, the distance from it. So if it was negative, it would have become a positive, but they're all zeros, so they're all going to be zeros. All right, so let's draw a dot plot. Well, we've got 18 and we've got 7 people, so that means 1, a 2, a 3, a 4, a 5, a 6, and a 7. That's it, right up the middle there. So the last part there is the mean absolute deviation. All right, the mean absolute deviation. So mean absolute. So what we do is we add up all the absolute deviations. So 0 plus 0 plus 0 plus 0. Yeah, you get the idea here as well too. That's going to end up giving us 0. So when we add them all up, we do get 0. And then we have to divide by how many there are. And then there is 7. So yeah, it's going to be 0. And let's think about it. What's the average distance it is away from the mean? Well, they're all the same. So yeah, that's why it is going to be 0. No one is further away from it. So let's watch what happens here. So now we're going to change the weight of just Alicia's, okay, to 17 pounds rather than the 18. So we want to draw a dot plot first of all. Okay, so that means we do have one person at the 17, and that means everyone else is at 18. So we got 1 person, 2 people, 3 people, 4 people, 5 people, and 6 people. All right, so it didn't change much. Where'd you go? There you go. Where'd you go? There you go. So it's not going to change much of our information. Are you seeing that too? Get back there. Okay, so it's not going to change much of our view. Okay, we're going to let it go. That was not my eraser, by the way. So what we're going to do is look at, without doing any calculations, how is the mean affected by the lighter weight? Okay, mean, the average amount. Well, if one of the what's the word I'm looking for? One of the weights, one of the backpack pounds goes down, that's going to affect the average. And again, think about it there. If you got all perfects on all of your papers, 18 out of 18s, and then one you got a 17 out of 18, yeah, it's going to make it a little bit smaller. Your averages, your mean is going to be a little bit smaller. Not really going to affect much, but again, it's going to make it just a little bit. Now, without doing any calculations, how is the mad? And I'm talking mad here. How is the mad affected by the lighter weight? All right. Would the new mad be smaller? Smaller, or would it be larger? Well, it's actually going to be larger here because remember, what is mad? That's the average distance. The distance, all right, away from the mean went up. Not by much. Went up by 1, but in this case here, it's going to, instead of 0 divided by 7, all right, that's what we had before, this time it would be 1 divided by 7, which is going to change it. So let's look at one more thing that we've got going on here. So suppose that in addition to Alicia's backpack changing from 18 to 17s, Fred's backpack has changed from 18 to 19. So we got 1 person at 17, we got 1 person at 19, and that means we got 1, a 2, a 3, a 4, and 5 people that are there in the middle. So once again, without doing any calculations, what would be the value of the mean compared to the original mean? And why? So let's see here. So the value of the new mean. Well, the new mean compared to the original. Well, it's actually going to be the same. All right. And let's keep this in mind. It's the average. So even though one person went down, the other person went up. Hey, when we add them all up, we're still going to get that same original amount. Now, again, we could add them all up, but it did say to do without any calculations. But yeah, the average is going to be 18. One's lower, one's higher. We still have an average of 18. So what would the value of the new mean compare to the original mean? What would the value of the new mean compare to the original? It's going to be the same. So it's 18, and well, the new one's going to be 18. And again, we're going to say the average because the 17 balances. We can say this balances the 19. And again, if we think about what's the average between 17 and 19, it would be 18. So without doing any calculations, would the mean for the new distribution be the same, smaller, or larger than the original? Well, once again, we are going to be larger because let's think about it. To figure out the MAD, you need to add the deviations. You need to add the absolute value. All right, so when we do that, even though this is -1 away, all right, the absolute value of it actually ends up becoming a 1. And this is 1 away, so that's also going to be a 1. So now it's going to have a total of 2 when we divide it by 7. Again, it's not going to change it by much, but it's certainly going to increase it. And that's the difference there, is it does increase the MAD, but it actually doesn't affect the mean at all. Let's see what we got here. Oh my goodness. We got 7 second graders. Now this is nice. There's second graders. All right, only 5 pounds a bag. That's good. We wouldn't want them the opposite there. So let's see here. So how is the distribution of backpack weights for the second graders similar to the original distribution for 6th graders given in the opening exercise? Well, hopefully we should notice, and we just don't want to go, they're all the same. Okay, but again, how is the distribution? Okay, how about something like same, but let's talk more about that. How is the distribution of backpack weights for the second graders similar to the distribution? How about this? No deviation from the mean. All right, they're all the same. Okay, we get that there, but we're talking about distribution. Distribution is how far apart they are, and there's no separation that's from it. So again, we just don't want to say the same because that's just not good. Yeah, exactly. That's exactly what I would say there. How are the means different? Well, the means. Now remember, the means are the average amount. Well, the average amount would be, in this case, if they're all the exact same, the average amount is, oops, my goodness, is 5. Because again, they are all the exact same. So the average amount is 5. Whereas before it was 18. But again, this is the thing is, the deviation did not change at all. But now the mean has changed. So that's kind of what we want to watch for, is just because one item changed doesn't mean it's always going to end up changing. All right? Now watch what I'm going to do here. Watch what I'm going to do. Ready? 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 Oh, no. Yeah, the way this question works out, I was not a big fan of it. I know you're disappointed that we're not going to be doing this one right now, but we're going to talk about it in class, so don't worry about it. That's it, people. That's all we got.